Hello, boys and girls. We are back again. We are talking math. We are talking topic 5, lesson 5. It can be found on pages 132 and 133. I'm going to share the book that is online, and it is called Lesson 7-4. It is not the same as ours. Okay, this top part with these unit bars, these fraction bars here, this is the same as ours, but all the answers, questions and answers are different. Let us take a look. Let's take a look at equivalent fractions. Look at these orange ones right here. Look at this orange one right here. Notice that, for example, if I have 1/6 and 1/6, notice that 2/6 is the same as 1/3. Notice here are the key words: same amount, different number. Look, 2/6, 1/3. So, same amount, different number. Look at it compared to 3/9. Look how 3/9 is the same as 1/3 in the area that it occupies. So again, same amount, different numbers. Make sense? Notice that the questions on this page are different than your page, 132. And all these problems here are different as well. So let's share your journal, okay? I'm going to go, sorry guys, let's share my journal. Here is your book. I'm going to take some of these problems. Let's look at these right here. It says, write 2 fractions that are equivalent to each fraction given. Okay, so I'm going to take some of these. I've written them down, number 15, number 17. Here they are. Here's 15 and 17. I've spread these problems out on purpose. Watch how I can multiply by 2. For example, I can multiply by 2 and I get 28/32. Those are equivalent fractions. I want you to also notice that I just multiplied by 1. The power of 1. 1 is a powerful number. It's the loneliest number. So notice 2 divided by 2 equals the 1. That's what I'm talking about. I just multiplied and I got that fraction. Since I spread this out over here, notice that I could divide by that. If I divide by that, I now get 7/8. So notice I have 3 equivalent fractions. Different number, same amount. Different number, same amount. I could double these again. Multiply this by 2 again. What do I get? 56/64, right? I could then take this number and go, well, I don't know, let me divide by 8. What do I get? 7/8. I get the same one here. Those are all equivalent fractions. Easy, easy. Let's take a look at another one. Notice I could divide if I wanted to. I'm going to go this way. I look at this. I could divide by 6. I get 1/4. Make sense? I could come over here and say, I don't know, it doesn't always have to be 2 like I did before. I could multiply here, multiply by 3, and I get 18. Multiply here. What do I get? 72. I look at this. I go, well, I don't know. I could divide again. What do I get? 2/8. Is it 2/8? I'm working quickly. Do you see all the equivalent fractions? They're too easy. Let's pick another one. Number 20. Number 20 looks like this. They give you 20/48. I'm going to give myself some space here. Okay, notice, I will slow down for you. I could divide. I could divide this by, I don't know, so I want to divide it by 4. Notice again that I'm really dividing by 1. What do I get? I get 5/12. Notice that this number is prime now, so I can't divide anymore. But I could come over here. I could double this. I get 40/96. Easy, right? Questions? Let me see another one. How about this one? 13. 13. Watch if I get this one, 7/12. They give you 7/12, and I'm thinking to myself, can I divide? No, I cannot, because this is already a prime number, so I cannot divide. Can I multiply? Of course I can. I could multiply by 2. I have 14/24. I could multiply by 2 again if I wanted to. You guys see them? What happens if I divide by 4? If I divide by 4, I end up right back where I started. So do you see the equivalent fractions? I want to look at a couple word problems here. Take a look at this one. This is on page 133. I want you to look at this problem right here. How can you use equivalent fractions to know that this big giant fraction is between these little fractions? Is it? I also want to do this one. Let's do this. I've written them down in my journal. Lynette says that 2/3 is equal to 4/9. Is she correct? Let's do this easy one first. Oh my gosh, that's too easy. Ready? Here's Lynette. Lynette says that 2/3 is equal to 4/9. Is she correct? I don't think so. Because if I had 2/3 and I were to get to 4, how'd she get to 4? She clearly multiplied that by 2. When I multiply that by 2, I get 4/6. How'd she get that? So Lynette is wrong, right? This is correct here. Lynette's wrong. Let's look at that other one. It looked like this. It said, how could I use equivalent numbers to prove that this ugly fraction is somehow between these little fractions? Is it? I think it is. Let's look at this 5 here. If I were to block one of those there, I'd go, how'd the 5 become a 20? Multiply by 4, correct? Follow this again. Look. How could that 5 become a 20? Multiply by 4. When I move my thumb, I would just multiply by 40. Do you see it? 5 became a 20 by multiplying by 4. Be 40. So if I do that, what do I get? 1 times 40, I get 40 200s. Look at the magic. Let's go the other way. If I come over here and I go, how could that 4, I'm going to try the same thing again. Let me get the pen out of the way. How could the 4 go into 20? How'd the 4 become a 20? Multiply by 5. Add the 0, it's a 50. Do you see it? 4 into 20 is 5 times 50. So if I go like this, I'm going to multiply going this way. I'm going to multiply 4 times 50, 200. 1 times 50 is 50. So here's the 2 new fractions. That's supposed to be a 40, not a 46. So clearly, this weird fraction here is in between those two fractions. Do you see how equivalent fractions can be helpful to you? Notice we went from little fractions, little numbers here, to these big numbers here. That is today's easy lesson. I need you to do the R and P page. Send me any questions. See you in the classroom soon.